Regular polygons with 5, 6, 7, and 8 sides are inscribed in the same circle. No two of the polygons share a vertex, and no three of their sides intersect at a common point. At how many points inside the circle do two of their sides intersect? I want to first start looking at a regular hexagon and a regular pentagon inscribed in a circle, so the 5 and 6 sided. And drawings may not be the best, but so this will be the pentagon. And then the hexagon. Okay. So the endpoints of the hexagon are here. Not the most accurate, but you get the idea. So something to note is the central angle of a hexagon, a regular hexagon, so from there to there, is 360 divided by the number of sides, so 60 degrees. And the central angle of a pentagon is 360 divided by the number of sides, which is 72 degrees. So because the central angle of a pentagon is more than the central angle of a regular hexagon, then each vertex, like if we look at each side of the pentagon, we see that each vertex of the hexagon is in between two vertices, and there's one intersection here and one intersection there. And there isn't any more or any less because the central angle of a regular hexagon is less than a regular pentagon. And even for an example of, like, let's say now we look at the pentagon. Close enough. All right, so regular pentagon. And let's even think about a shape with more vertices. So like, say the vertices are all so connecting these, this is inscribed too. So this shape, and let's just say this shape on the outside with a lot of vertices is regular. This clearly has a central angle that's much smaller than that of the pentagon. And we see that even as the number of vertices increase, so here to here, it's not yet going through a side of the pentagon, but eventually it will go through one side. And it will go through a side here. And that's true for every side of the pentagon. And so if we count the number of intersections in each of these cases, it's for every side of the pentagon, there are two intersection points. So the number of points inside the circle where two of their sides intersect is just 2 times the number of sides of the shape with less sides. So 2 times 5 is 10. There are 10 of these points. And the reason why it's important to consider these are regular polygons, is one last drawn out example here. So draw a regular pentagon again. And let's say we consider a shape like this. Okay, so this shape with the vertices here. So here's the regular pentagon, and this shape has 7 vertices, and it's clearly not regular. So we see that it intersects the pentagon twice here, twice here, twice on this side, and twice on this side. It intersects 6 times. But this is a septagon. If it were a regular septagon, then the number of intersection points would be 2 times 7. But since this angle right here, this angle is bigger than that of the central angles of the regular pentagon, it completely bypasses this side. It doesn't intersect this side of the pentagon at all, and same here, it doesn't intersect that side of the pentagon at all. So it's key that these are regular polygons. And lastly, to bring up the point of, this is saying that no 2 of their polygons share a vertex. So like, to bring a simple example, we have like a square and say an equilateral triangle. These are both inscribed, and we have 2 intersections here and here. And then since they share a vertex here, there are only 5 intersections. Whereas if they didn't share any vertices, and this was an equilateral triangle and a square, there would be 2 times 3, which is 6 intersections. But since they share a vertex here, that's not the case. So it's good to note that no 2 of the polygons share a vertex. And we're given that no 3 of their sides intersect at a common point. So we're really just looking at, we can think about these just 2 polygons at a time. So the points where we know that no 3 of their sides will intersect at a common point. So just 2 of their sides will. So comparing all the different polygons then, basically, given 2 regular polygons inscribed in a circle, let's say one with m sides and one with n sides, let's say m is greater than n, the number of intersection points will be 2 times n. For these regular polygons inscribed in a circle. So we can just go down the list. So for a 5-sided and a 6-sided regular polygon, number of intersection points, we take the lower number, and we already found this out, is 2 times 5, which is 10. 5 in the 7-sided, it's going to be, again, 2 times 5. 5 in the 8, 2 times 5. And then 6 and 7 is 2 times 6, which is 12. 6 and 8, 2 times 6, which is 12. And then the 7-sided and the 8-sided, comparing those, it's going to be 2 times 7, which is 14. So we add all of these up. So 10 plus 10 plus 10 plus 12 plus 12 plus 14. And when you add that up, it comes out to 68. So there will be 68 points inside the circle where two of their sides intersect. So the answer is choice E.